We ended on specific heat, na? Specific heat तो समझ में आ गया होगा. I shouldn't be repeating again. Yes, no. পঢ়াচোন আগতে এইটো. ৰবা এইটো পঢ়া. ৰবা. Read the first point and tell me what you understood. তোমাকে কৈছো.
Specific heat capacity is the property of a substance which determines the change in the temperature.
Determines the change in temperature of the substance or undergoing no phase change. Matlab, okay, I'll come to this one. For now, just read that. It's a property of a substance which determines the change in temperature of the substance when a given quantity of heat is absorbed or rejected by it. Matlab, when a heat is provided to a substance or to a material, that material, how much that material is accepting the heat, how much matlab, what quantity of heat is being accepted or what quantity of heat is being given off, that is what we call as the specific heat capacity. Also, you can also define it as the amount of heat per unit mass. If this is your specific heat, amount of heat per unit mass absorbed or given off by the substance to change its temperature by 1 unit. Just by 1 unit, चेंज करने के लिए कितना हीट चाहिए और कितना हीट ले रहा है और कितना हीट दे रहा है, it is what we call as the specific heat capacity. It's in the name, specific heat capacity. If we divide the names, if we divide the terms, sorry, not names, the heat capacity, matlab the capacity of that substance to absorb or give off the heat. Specific matlab specific for that substance. That substance will, how much it will take or how much it will give up, that is very specific to that material only. So that's why specific heat capacity. Okay, understood? The formula is given by this one. Okay, small s per mass and change in heat or the amount of heat divided by the change in temperature. Okay. SI unit is joule per kilogram per Kelvin. Sometimes they will also give it in joule per kilogram per degree Celsius. It's the same thing. Okay. In SI unit, we sometimes keep on changing between Kelvin and Celsius. Fine. लिख लो ये definition लिख लो. Show me the question answers that we did in last class. Do you have it with you? Okay. Okay, heat. Okay, this is specific heat. Specific. Why your pages are outside of your copy?
Because I didn't do my copy.
Oh, acha.
So I had to do another copy. And I don't want to write it down, so I'm going to paste it. Thermal expansion.
Yeah, we also did thermal expansion. इसका जेरोक्स लेके फायदा नहीं होगा. कुछ समझ में नहीं आएगा. I understood. Okay, today we have to finish this one, this chapter. No major chapters. After that, it's all up to you guys. Keep on studying. If some problems you get, fix one class with the sir. I'll come. If you want revisions and all. PYQ, PY4, for PYQ, we might take one more class, but not recently. Maybe after some days for PYQs and all. What's the date?
Which one?
CDS or whatever the exam is coming.
FCAT is there.
February. Will
So far, I haven't seen questions related to these equations.
FCAT, yeah.
It's just some terms,
Terms
facts.
of-
And then
Mostly it's in
CDS,
CDS is when?
April 21st.
Okay, you have time. Lots of time. And when is NDA?
NDA and CDS is conducted on the same day.
Oh, acha, okay. Okay. I don't know. Is it? It formula likhiba.
Same. NDA and CDS is conducted on the same day.
Then fine, you have time. NDA is a bit. Okay, now we have studied about per mass, amount of heat required, which is per unit mass. Okay, we have studied. Now we have studied with regards to mass. Now, what if you don't have mass? But like you don't have mass means what if the mass is not given? Sometimes they will, sometimes in the questions or sometimes in numerical problems and all, they might refer to something called moles. Do you know what is moles? Moles. What is it? What is mole? What is one mole? What do you mean by one mole? Sorry. Hmm? Okay. Say for example, you have a beaker of glass. Again, beaker of water. You have a beaker of water. Now, just imagine that you took a portion of this water, just a little portion of this water, and after doing lots of experiments and stuff, you found out that in this little portion of water, there are approximately 6.022 into 10 to the power 23 molecules of water, molecules of H2O. Now, this number is what we refer to as 1 mole. So 1 mole. So mole is basically a quantitative tool, or you can say a tool through which you can measure how much, what is the how much substances or how much particles are there in that region. Okay, so that is how we refer to as mole. So sometimes without giving mass or without signifying the mass, they might refer to moles. And 1 mole, like I've said, is 10 to the power. Units can be any units here. Basically, mean molecules or particles. Okay. So in that case, how we define the heat capacity per mole? So in that case, when the mole is used instead of mass, then we call it as a molar specific heat capacity. We then call it as molar specific heat capacity. Same, the formula remains the same. Just in place of mass m, we replace it by mu, which is mole, and then again everything is same. Okay. And also again, in the SI unit of molar specific heat capacity, instead of kilogram, we use joule per mole per Kelvin, or sometimes they might also give joule per mole per degree Celsius, but it's both the same thing. Okay, understood? Molar specific heat basically means that if we don't use mass, then we use the term called moles, 1 mole, and 1 mole consists of 6.022 into 10 to the power 23 molecules. So 1 mole of a liquid or 1 mole of a substance contains approx 10 to the power 23 say particles or molecules, whatever it is. Okay. Now, so far we have discussed this specific heat capacity, smaller specific heat capacity in terms of solids or liquids. In terms of solids or liquids. Now, what happens when we talk in terms of gas? So, in case of gases, certain conditions are needed. It's not like you have provided heat. It's taking some heat, it's giving off some heat, and then you have got specific heat capacity. And this, it's not that case actually. In gases, first thing is that you have to hold it under constant pressure. This is the first case. You have to hold it under constant pressure during the heat transfer. In that moment, what we call is that the molar specific heat capacity at constant pressure. First of all, which is denoted as Cp. Second case is that sometimes the volume is maintained during the heat transfer. Then it's what we call as a molar specific heat capacity at constant volume denoted by Cv. Got my point? In terms of gases, either pressure has to remain constant or either volume has to remain constant. Then only you can find out the specific heat capacity. Understood? And the formulas are same after that. These are the two conditions that is needed while dealing with gases. Understood? One is molar specific heat capacity at constant pressure, and one is molar specific heat capacity at constant volume, Cv and Cp. Fine. Calorimetry is basically इतना जानने का है नहीं इसमें. Calorimetry means measurement of heat. Calorimeter is the device through which you can measure the heat. यही था तुम लोगों के लिए जानने के लिए. Calorie, I don't know. I haven't found any equations, and also I haven't found any questions related specifically to calorimetry. We have done these questions, no? This one. Second one is huge. I don't know why I gave you guys. This is not very nice. But if you want to do, we can do it by the end of the class. Okay? You have to do lots of things. Fine. Moving on. Change of state. Okay, change of state. How many states are there in this universe? Huh? 5. What are those? So there are Bose-Einstein is the 5th state, not 4th state. One is solid, one is liquid, one is gas, which we can feel in our day-to-day life. Next comes plasma, which is found in sun. The sun जो burn हो रहा है, this is plasma. Sun का state plasma है. It's not liquid, it's not gas, it's not solid. It's plasma state. And then one is found below zero temperature, मतलब minus temperature, which is what we call as Bose-Einstein condensate. This one you will learn in masters. This one you will learn in degree. This one you will learn in school. This one you learn in, if I remember correctly, second year. You just start learning in second year. Then in masters first year you go in depth. Both. Anyway, we need to deal with only solid, liquid, and gas. Okay, some very basic things which you already know, but still let us go through anyway. Change of state. Bose-Einstein condensate, in a very simple way, I will say that state of matter when the temperature dips down below 0 degrees Celsius. In that cases, how the particles. Now, as we know, there are not, as basically we know what, there are proton, there are electron, and there are neutron. Neutron is neutral. It's neither positive nor negative. It's neutral. Then we know that in the nucleus, that means in the center, it is made of what? Proton and neutron. Then on the orbits, we know that it's electron revolving around. Then further we came to know that okay, these are not the basic elements. इसके भी और नीचे है. Now electrons are made up of what we call as quarks. There are 6 types of quarks. Okay, there are 6 types of quarks depending on how they are present in the universe. Then it's up, down, strange, something names are given. Then again we found out that quarks are not the basic elements. इसके भी और नीचे जाना पड़ता है, which we call as fermions, then gluons, then muons, lots of things. So when Bose and Einstein, when they started working on this fermion, they found out that they behave very peculiarly when they are in a very low temperature. So later they found out ultimately it's a state of matter only. So that is what we call as Bose-Einstein condensate. In that case, the particles, now these are all microscopic particles. These microscopic particles behave very peculiarly in that temperature. This is how we, and that field is how what we study as Bose-Einstein condensate. Okay. Anyway, first of all, since I mean you know guys, but still we have to go through change of state from solid to liquid is what we call melting or fusion. लिखना है तो लिखो, नहीं लिखो, you know this thing. Liquid to solid, freezing. Change of liquid to gas, evaporation or vaporization. Fine, we know these things. Now, read this one. It is observed that the temperature remains constant until the entire amount of solid substance melts. Okay, what do you mean by this? Just this line. Ice. You have ice. Ice temperature is below 0 degrees Celsius. That's why you are getting in solid form. Now you are giving some temperature to it, some heat to it. Say this ice was in temperature. Say this ice was in temperature minus 20 degrees Celsius. Now you are giving heat. As you are giving heat, the temperature is rising. Temperature rise hote, it has reached 0 degrees Celsius. Now we know that at 0 degrees Celsius, we get what? We get melting point. At 0 degrees Celsius, ice melts. Minus 20 is much more smaller than 0 degrees Celsius. To reach 0 degrees Celsius, you have to provide lots of heat. Providing lots of heat, matlab temperature is also increasing. Now, 0 degrees melting point. Say this ice has a mass of 500 gram. You are providing the heat. You have provided the heat. The temperature has reached 0 degrees Celsius. Until and unless all this 500 gram mass of ice melts into liquid, doesn't matter for how many time you provide the heat, the temperature will always remain in 0 degrees Celsius. After this whole 500 gram has melted into liquid, then again the temperature will rise from 0 to 1, 2, 3, 10, 15 till 100. At 100 degrees Celsius, we know that liquid turns into vapor. That means it's the boiling point. 500 gram of ice has changed into 500 gram of liquid. Now, at 100 degrees Celsius, until and unless this whole 500 grams of liquid doesn't change to gas, it doesn't matter for how many time you provide the temperature, provide the heat, the temperature will not change from 100 degrees Celsius. This whole 500 gram of liquid has changed to 100 degrees, changed to gaseous state. Then only this temperature will then again start changing. Got my point? तो मतलब जब तक पूरा amount, the whole substance doesn't get transformed, the temperature will remain the same. This is what it means, matlab. So it is observed that temperature remains constant until the entire amount of solid substance melts, solid or else liquid, whatever you have got. That is both solid and liquid. That means it means that both solid and liquid states of that substance at that point is coexisting. Now a completely solid भी रह रहा है, now a complete liquid भी बन रहा है. They are coexisting in that point. Fine. And this is what we call as the thermal equilibrium during the change of states from solid to liquid. I think I have the graph. Wait, I'll show you the graph. Graph देखने से you will understand clearly. This graph is not that precise. I want this one. Yeah. See, below 0 degrees Celsius, below 0 degrees Celsius, temperature is rising. Then it has reached 0 degrees Celsius, which is the melting point. Melting point, for some time, the temperature has remained the same. Now the whole thing has changed. Then again, the temperature is rising. Liquid phase pe hai abhi. Temperature is again rising. Now it has reached 100 degree. Now, until and unless the whole mass of that liquid changes to gas, the temperature will remain same. And after change of that whole mass, again the temperature will rise. Got the graph? This is how it happens. Fine. Okay. Okay, लिखना है. अच्छा, थोड़ा सा लिखो. Melting point वगैरह वगैरह you know, so I won't be playing on that much. Write the last point. What in whatever way you can write this thing also, or in whatever way you have understood, you can write. This is how the thermal equilibrium is achieved. Thank you. Melting point, freezing, melting, freezing, evaporation. अपने आप से लिख लेना. You know only, so I won't be playing on that much. Okay, जल्दी लिखो. Done. Okay. Okay, understood how the temperature remains constant. So, the temperature at which the solid and liquid state of the substance is in thermal equilibrium with each other is called the melting point. That means the 0 degree Celsius. This is the actual definition of melting point. Normally, how we define? We say that the temperature at which the solid substance melts. This is what we call as 0 degree Celsius or the melting point. But in actuality, the temperature at which the solid and the liquid states of the substance is in thermal equilibrium. That temperature is what we call as the melting point. They might ask you either way, matlab. They might ask you in many other ways. Okay. In actual, this is how you define melting point. Actually, not that solid substance or the ice melts at 0 degree Celsius, so it's melting point. No. After that, we have to learn a very important thing: regulation. Okay, लिख लो ये. I'll come to it. Okay, done. Now look at this word regulation. Have you ever wondered how the ice skaters skates on ice? Huh? Have you guys wondered that these ice skaters they can skate or they can slide on ice, but how does it happen? Any idea? How does it happen? It happens through a process what we call as regulation. Regulation, na? Or relegation? Regulation. Regulation in this phenomenon, pressure works a vital role. Okay, pressure. Now, regulation happens because of pressure actually. So, okay, let's do an experiment again. Fine. Say you have a huge block of ice. Huge block of ice, say mass 2 kg or 3 kg. It is supported on the edges, it is supported on a rectangular beam. Okay, it is supported on a rectangular beam. I mean, thoda galat ho raha hai, but fine, you will understand. Now, from the edges, this is ice, as you know. This is ice. From the side, I attach two weighted substance. Okay, say for example 1 kg, and also on that side. Oh, sorry. And also on that side, okay. You got my point. On that side also, I have attached one more weight, which is again 1 kg. Matlab this has a weight to it. Matlab how to show? Okay, yeah. This is the block of ice. This is the block of ice. A thread is, so the weight is like this. So the thread is going in this way. Okay, and on the two ends of the thread there is weight. Say for example 1 kg or 2 kg weight is there. Now give it some time. Say for example, give it say 1 hour. What will happen? What will happen to the ice? Will the ice break because of the pressure, or will the ice say will change its state from solid to liquid because of the pressure? See, ultimately it's happening all because of pressure. What will happen? Will the ice break because of pressure? Will it change its state? How? There is no heat, whatever. what happens is that if you give it some more time, say 1 hour to 2 hour, and let the weight rest on this block of ice, the weight will come crushing down. Understood? The weight will come down. It's like the weight is slipping inside the block of ice. Okay. What it does is that, so if this is your block of ice, I'm giving you the side view. First of all, it's here. The say the thread is here. Now you give some time and the thread will come down. That means what? This portion is melting. That's why it could come down. Now, as soon as the thread has come down to this position, again this part will get transformed to solid because there is no longer pressure in this region. Yeah, it happens that way. Again, say in this portion, the ice is melting, that's why it's going down. Because of the ice melting, it's going down now. Now, as soon as it leaves the second region, the thread leaves the second region and comes to third region, this whole part will again get transformed to solid state. That's why the ice don't break. अगर पूरा liquid ही होता रहता ना, the ice would have broken down at one point or would have gone to liquid state at altogether, but it doesn't happen. Okay, so this process or this phenomenon is what we call as regulation. Understood? Can you visualize in your head what's happening? If you can visualize it, then you have understood the part. So this is what we call as regulation. Regulation is a phenomenon observed in certain materials, particularly ice. See, particularly ice, where melting occurs under pressure and then refreezing happens when the pressure is released. Got my point? Sorry. This process allows ice to melt at a temperature lower than its normal melting point when subjected to pressure. So, like I said, this phenomenon only happens when pressure is involved, and only in this phenomenon, ice will melt below its melting point, below 0 degrees Celsius. Ice will melt only in this phenomenon because all what is doing is the pressure is playing a vital role. Okay, now this is how skaters skate on ice. How does skaters skate on ice? Okay, this is a large, say this is just a portion of that ice field. Okay, now if you see the shoes of skaters, if this is the this is the shoe. Now there is this blade on the shoes. Okay, very sharp pointed blades on the shoe. Now what this does is that, now what's the formula for pressure? The basic formula: force per area. The area of this edged part is so thin that it gives lots of pressure on the ice because pressure is inversely proportional to area. Okay, so it exerts so much pressure on the ice that jahan pe the position where the skater is there, on that position the ice melts instantly. Now since the ice has melted, friction has become less. Now since there is no friction, they slide easily or they slip easily on the ice. This is how they go. So जहाँ पे भी वो जा रहा है ना, they are forming patches of water actually. They are forming patches of water. Now as soon as they leave this position and move to another position, this part will again freeze back. Understood? This is how the skaters skates on ice. Okay, understood? फाइन लिख लिया जो लिखना था थोड़ा जल्दी करो सॉरी টোপনি লাগিছে কিবা খাই আছানে Okay, now we have studied in case of solid. Now say in case of vaporization. In case of vaporization, we also see that temperature, same again that I have said, when changing from liquid to gaseous state, until and unless the whole substance doesn't transform, the temperature remains the same. And this is how you define the boiling point. The temperature at which the liquid and the vapor state of substance coexist, it's what we call as the boiling point. Now, tell me one thing. You guys have used pressure cooker. That is how you make rice. Anna, read the line. With the increase or decrease in pressure, the boiling point also increases or decreases respectively. That means if pressure increases, boiling point increases. If pressure decreases, boiling point decreases. Now, I'll give you one question. You might take it as a homework also. Pressure cooker or making rice in pressure cooker, where it happens faster? On sea level or on top of the mountain? राइस जब बनाते हो जल्दी कहाँ होगा ऑन द टॉप ऑफ अ माउंटेन और ऑन द सी लेवल व्हाई बोलो तो
because top of the mountain pressure less होता है.
प्रेशर लेस होगा तो बॉइलिंग पॉइंट कम होगा और तो बॉइलिंग पॉइंट कम होने से तो ज्यादा हो जाएगा ना जल्दी होगा कुक तो बॉइलिंग पॉइंट इंक्रीज होगा कि डिक्रीज होगा ऊपर ये छोड़ो तुम खुद से बोलो यू आर इन हाई एल्टीट्यूड दैट मीन्स यहाँ पे प्रेशर कम है मतलब बॉइलिंग पॉइंट इंक्रीज होगा कि डिक्रीज होगा एंड एट द सी लेवल प्रेशर ज्यादा है कंपेरेटिवली प्रेशर ज्यादा है तो यहाँ पे बॉइलिंग पॉइंट इंक्रीज होगा कि डिक्रीज होगा अच्छे से बोलो मतलब नॉट बोलो अच्छे से गो एंड डू दिस होमवर्क प्रॉपर्ली ओके सोचो हाँ ट्रिप भी हो जाएगा एक वो प्रेशर कुकर लेके जाना एक काम करना सेंड 2 to 3% on our west Khasi Hills and 2 to 5% on our sea level say for on
This is directly proportional.
हाँ
तो sea level में ज़्यादा होगा ना.
boiling point do this experiment actually फोन पे रहना you keep on contacting they will let's start the experiment and at exact point you both start the experiment and note the time it will be a very good experiment try to do it okay Why I'm stressing on this one? क्योंकि इसके ऊपर आया था question. That's why in CDS last year ही आया था. However, all substance do not pass through the three states. मतलब from solid to liquid to gas, not all substance do that. Sometimes some substance go directly from solid to gas. Change from solid to vapor state without passing through liquid state is what we call the sublimation process. And the substance is said to be sublime. Okay. And during the sublimation process, both अभी क्या होगा solid and gaseous state will coexist in a thermal equilibrium temperature, in a thermal equilibrium position. Earlier, during melting point or something point, either solid or the liquid stays in coexisted, or either liquid or gases coexisted. But in sublimation process, both the solid and vapor state of a substance coexist in thermal equilibrium. Understood? Okay. This is the graph that I was melting point stays for a while, whole thing changes state, again temperature rises, and then as the whole changes, it remains the same, then again temperature rises. Coming to latent heat. Okay, what was the definition for specific heat? Tell me. Give me the mathematical one. Mathematical one. देख के बोलो, देख के बोलो. Give me the mathematical one.
Per unit mass.
Per unit mass.
Amount of heat per unit mass when a substance changes temperature by 1 unit.
Change in temperature by 1 unit. Keep that in mind. Huh? In specific heat, we discuss change in temperature by 1 unit. In latent heat, this is where it differs. In latent heat, the amount of heat per unit mass transferred, we are talking only about transference, okay, transference of heat during change of state of the substance is called the latent heat of the substance of the process. जितना heat transfer हो रहा है, that is what we call as the latent heat. In specific heat, we discuss both transfer and getting rejected. Specific heat, we discuss both. कितना heat transfer हो रहा है, कितना heat reject हो रहा है. In latent heat, we only talk about transfer. कितना heat जा रहा है बस वही. लिखो. At least the formula. Sorry, at least the definition and the formula. This is the formula. M is the mass, L is the latent heat, Q is the quantity of heat. Okay. M is the mass of substance, L is the latent heat, and Q is the quantity of heat required to achieve that amount of latent heat for a specific mass. Amount of heat required to achieve this amount of latent heat for a specific amount of mass. This is how you can remember the formula. This is how the logic you can apply. Do one thing. Check the SI unit of latent heat. Is it -1 or is it a typo? You have to put chota nikal gaya, so maybe it's a typo or something. Just check once.
kg or kg to ml.
Okay, yeah, you are correct. Q is equal to ml ना, L Q by M, mass हो जाएगा inverse, Q हो जाएगा, yeah, okay, correct. This is inverse one. Okay, let me write it correctly. Joule kg inverse. Also, value of L depends on pressure. And okay, F V. Fine. Look at this one. ये लिखो, ये इसी वे लिखो, कोई बात नहीं. And comma करके also depends on pressure ऐसे लिख के रख दो. Coming to the third point, the latent heat for solid liquid state change. Solid to liquid अगर change हो रहा है state, that latent heat is what we call as a latent heat of fusion, denoted by L small f. And the latent heat for liquid gas change is what we call as the latent heat of vaporization, denoted by LV. Solid to liquid, latent heat of fusion. Liquid to gas, latent heat of vaporization.
Subscript में LF होगा.
LF for fusion, LV for vaporization. Whatever the value you get, that you denote it as LF, or whatever the value you get, denote it as LV. Okay. 0.15. Okay, understood so far? So far everything is clear, I guess.
Yes, sir.
Okay, well, try the first question. No, no. I mean, you can get the slide from the website. So up to you. लिखना है नहीं.
Tomorrow also will have.
No, this is the last of physics. If the guys who have come late, if you want some revision classes, then I can take. There's no problem in it. But formally, this is the last class. What they are asking to find? Latent heat of fusion of ice. Specific heat of water is given 4186 joule per kilo per Kelvin. Okay, when 0.15 kilo of ice at 0 degrees Celsius is mixed with 0.3 kilo of water at 50 degrees Celsius. Okay, matlab temperature of ice is 0, temperature of water is 50. In a container, the resulting temperature is 6.7 degrees Celsius. Calculate the heat of fusion of, matlab latent heat of fusion of ice. How will it do? First, take out how much heat is lost by water. कितना हीट पानी लूज कर रहा है वो पहले निकालो. Then, okay, before finding out, tell me what will be the temperature difference in the loss of heat by water. Which temperature you will take? कौन सा temperature you will consider? 6.7 is the final temperature. 50 will be the initial temperature, or 50 is the initial temperature, or 6.7 is the final temperature.
50 is the initial.
Sure.
50 degrees Celsius with resulting temperature is 6.7. So 6.7 is fine.
Heat loss by water, you will be, what's the formula? What is the formula? Q equals mass times specific heat times change in temperature. Okay. लिख लिया ना question? Okay. Then I can skip to fine. Okay. First, let us find out how much heat is lost by water. So heat lost by water. What's the mass of water?
0.30.
मतलब 0.3 kilo. Fine. What is the specific heat of water? Oh, okay. I didn't give you a specific. Oh no, यहाँ पे लिखा था ना. 4136. 4186 joule per kilo per Kelvin. 4186 joule per kilo per Kelvin. Change in temperature will be delta T for water.
Minus 6. But one is Celsius, one is Kelvin.
Transform it. Celsius to Kelvin कर दो क्या है? करो. Celsius to Kelvin, you know the transform formula. Let me see one thing. What's the thing? What's the 50 and 60? 50 and 6.7?
So use that right there.
Multiply. Okay, let me look for you. Follow. What's the 4186 multiplied by 0.3 multiplied by
43.3.
43.3? 543 माइनस नहीं मिला ओ नहीं
Here been minus का.
हाँ ये नहीं है ना
543.
54376.14 हाँ या ऑब्वियसली ये ना तुम बिना वो करके भी आ जाता है एक्चुअली
270 is common.
कॉमन ना दैट्स व्हाई
So this is Canadian.
so heat loss Q mass of water specific heat of water change in temperature 0.34186 50 what 50 minus 6.7 you get what was the answer 40.3 54376 5 5 4 3 7 6.14 what will be the SI unit mass जूल इसको तुम केल्विन भी रख सकते हो सेम आएगा पर केल्विन केल्विन गॉन पर मास मास गॉन जूल okay now this is the heat lost by water now find out heat required to melt ice which will now then you have to find out heat required to melt ice which is what heat required to melt ice say qw say qi latent heat mass of ice lf so mass is how much
0.15.
0.15 since we don't have lf so let it be lf we don't have lf that's the thing we have to find out now we're going to find out lf then after that heat required to raise temperature of ice water to final temperature I know it's confusing at first but keep on doing this kind of problem you will get to know now write heat required to raise temperature of ice water to final temperature thing is क्या हो रहा है you have ice then you have water now you are giving some temperature that ice will also melt ना तो वो उस आइस को मेल्ट करने के लिए कितना पानी जो है वो उसको पानी के लिए कितना चाहिए to get the water from that ice how much heat you need it now you have to find out that one got my point you have ice and then you have poured some water heat lost by water वो निकाल लिया heat required to melt the ice so you are giving heat then again heat required to raise the temperature of this ice water जो melt होगा ना उसका तो कुछ ice water निकलेगा उसको रेस करने के लिए कितना चाहिए टेम्परेचर वो निकालो heat required to raise the temperature of ice water to final temperature what was the final temperature in here हाँ वही ना कंटेनर का टेम्परेचर तक तो जाना पड़ेगा ना how will you go that's the thing ice water mass to ice specific heat of water 6.7 minus 0 mass of ice 0.15 4186 6.7 इसका होगा तुम्हारा आंसर 4206.93. 4206 for today. Just write it the way I'm writing next time. 4206.93. Fine. Now what you will do? इतना जो निकाला हम लोगों ने कुछ ना कुछ तो यूज होगा ना. Heat lost and these are heat gain or heat transferred. So now just simply heat lost equals plus heat lost equals heat lost equals heat lost equals और जो लॉस्ट हुआ वो तो गेन करना पड़ेगा. हीट गेन हीट लॉस कितना था हम लोगों का 54376.14. हीट गेन कितना हुआ 4206.93 प्लस 0.5 latent heat of fusion. माइनस करो 54376.14 minus 4206.93. How much? How much? How much? How much? How much? Did you understand what has happened so far?
There's only one. We have to check. Check the whole process.
नीचे रहेगा 0.15. नीचे रहेगा 0.15. ऊपर कमान इतना टाइम लगता है क्या माइनस करने 5 4 6. यहाँ पे पॉइंट कौन डालेगा ओ ओके ओके यू हैव अच्छा ओके यू हैव diminished the frictions okay okay everything is correct so I'll give you the answer directly everything is correct so I'll give you the answer directly so latent heat of fusion will be 3.34 into 10 to the power 10 to the power how much 3.34 into 10 to the power 5 अरे if you take the point बोलो क्या था
Oh, it's so stupid.
अंडरस्टूड क्या हो रहा है समझ में आया कि नहीं सी
Really so confusing.
they will ask you in such a way they might ask you in such a way ना they might ask you in such a way कि heat loss और heat required को करके तुम लोगों को निकालना पड़ेगा इतना आएगा they might not give you the second part उस तरह से आ सकता है there is a chance what is happening is ice then they have poured water heat final temperature of the whole container was 6.7 now in this 6.7 there is temperature of water also there is temperature of ice also how much heat the ice is losing the water is losing first you find out second now since you have given the heat ice will also melt it's not that the water will transform to vapor ice will also melt na ice melts तो कितना हीट चाहिए to melt the ice this is the one plus जो ice melt हुआ melt होने के बाद पानी भी तो हुआ ना, उस पानी को 6.7 तक ले जाने के लिए कितना टेम्परेचर चाहिए वो भी निकालना, कितना हीट चाहिए वो भी निकालना होगा. Now these two are heat required. Heat required first to melt and then heat required to reach this temperature. Simply do the equation with कितना heat lose हो रहा है. Because what we know, law of conservation. So if something is lost, something must be gained. So this has to be equal. That's how you find out. Understood? बहुत टाइम चला गया ना इसमें, पर कोई बात नहीं, सब करना चाहिए. Fine, you don't need to do this, but it's easy also. But anyway, this is the latent heat graph. See here, look at one thing. When the solid changes to liquid, the energy that is released is 80 kilocalorie, 80 kilocalorie per kilogram. And when liquid changes to gas, or like say steam or vapor, see the energy. That's why the steam burns more. That's why the steam burns more than say the boiling water or something. Because see the energy. 540. It's kitna? 540 minus 80. It's 460 times 460 more than how much it is required to change from solid to liquid. So it's very much. So that's why it is told na ki don't go near the steam, don't go near the vapor. When the pressure cooker, you're just opening the pressure cooker, don't stay directly close to that steam. It might burn you. And there are lots of cases where people have got burned. Okay? Coming to the last topic. Now we have understood about heat, we have understood about temperature, we have understood what types of heat, specific heat, latent heat. Now how the heat gets transferred. There are three ways through which heat gets transferred. First तो तुमने देख लिया, what are the second and third ways? Convection and last conduction, convection and radiation. See, I will make you understand in a very simple way. Conduction is basically heat transfer. You have a steel, this region is very hot and this region is cold. Now since steel is a very good conductor also, the heat will go from hotter region to colder region. This is how the energy is getting transferred. This is what we call as conduction. The heat is getting conducted from one side to another. Convection. What is convection? See, in conduction is the transfer of heat. In convection, it will be the transfer of literal particles. Particles will get transferred. High energy particles will get transferred to low energy region. Understood? This is how convection works. ये लिख दो और ये लिखो. What is the best example of convection? You have studied in class 8, I suppose. Matlab in class 8, you didn't study as conduction, convection, but that was the best example. Maybe class 8, 7. कुछ याद आया?
Heat transfer from a top to the
Have you heard of land breeze, sea breeze? These are the phenomenon of, or the examples of convection. I'll tell you what is TC and TD. First, just write the this one and write the formula. I will tell you कहाँ से क्या हो रहा है. Tc, Td, temperature differences at two ends of a material. K is thermal conductivity. L is the length of that material. A is the cross-sectional area of that material. Understood? Conduction, have you understood? Is the transfer of heat. Okay? Is the transfer of heat. Tc, Td. Tc and Td. K, A. Matlab it's written like this. H, K, A, Tc minus Td divided by L. Cross section, not area, cross section. Area and cross section area are two different things. This is a constant term. K is a constant term. Let me tell you ये TC TD, at least let me show you how it कैसे क्या हो रहा है, ठीक है? So that you get a good understanding how this formula has come up. Fine? Okay, I'm changing. लिखो लिखो. हो गया. Say this is a steel rod. Okay, this is a steel rod, and say for example, ये ना एक सिस्टम पे छिपा के रखा है ताकि the heat doesn't escape to the surrounding. That's why we have kept it in kind of a system. Okay, we have kept it in kind of a system so that the heat doesn't escape to the surrounding. ऐसे करने से ज्यादा अच्छा होगा. This is a system, closed system. Fine. Say the length is our L. यहाँ पे है तुम्हारा TC, यहाँ पे है तुम्हारा TD. मतलब this is TD, this is TC, and TC पे टेम्परेचर ज्यादा है TD से. Fine. And the mass, say for example, mass is what we take as M, and cross section area is what we take as A. Fine. Say this is very hot region, this is colder region, so according to conduction the heat transfer will take from TC to TD, and that formula is how we give as. And this is also, we know that H is proportional to cross section area. H will be proportional to change in temperature. H will be inversely proportional to the length. K, because proportional sign ko hata ke we have brought the equal sign, so you have to change it with some kind of proportionality constant, and that constant is K A TC minus TD by L. So can you now visualize it? कहाँ से कहाँ क्या हो रहा है for this formula? K value will differ from material to material, or maybe not. Let's see. Understood? ठीक है? कहाँ से कहाँ क्या हो रहा है? Fine. Okay. हाँ. So yeah, K will be obviously differ from material to material, but one important point about K is that the greater value of K का जितना ही value बड़ा होगा, the more rapidly it will conduct heat. And the SI unit of K is joule per second per meter per Kelvin, or watt per meter per Kelvin. याद रखना है ये सब. Today we'll finish it, no matter what. थोड़ा time लग जाएगा, but we'll finish it. ज़्यादा नहीं है, बस ये last topic. Now from conduction there are two things. from conduction there are two things. Matlab from this type of radiation flow or type of heat transfer, there are two things. Actually I haven't mentioned it. Matlab शायद भूल हो चूक गया शायद. Now this point that I will try to understand, this is what we call as heat retention. Heat retention, and this point is what we call as heat transfer. Though both are examples of conduction. Okay. Now, have you experienced this? You are living in RCC building. You know RCC building? There in Assam, there are two types. One is Assam type houses. This kind of house. For example, I'm giving not exactly, but for example, this kind of house. And RCC is just the buildings. Okay. RCCs are just the buildings, ground floor, first floor, second floor. These are the buildings. So this happens mostly in case of RCC buildings. You have a ground floor, and this is it. You don't have first floor. So in summer days, you will feel very hot inside the house because concrete, जो concrete है ना,
फर्स्ट फ्लोर नहीं होने से
मैं बोलूंगा नहीं होने से क्या होता है, होने से क्या होता है. Because क्या होता है कि the concrete, the thermal conductivity of concrete is still, हाँ,
फर्स्ट फ्लोर नहीं होने से छत नहीं रहेगा.
मतलब छत है, छत तो रहना ही पड़ेगा. Roof. This is the roof, for example, and this is your house. I'm just giving you examples. Okay. तो क्या होता है कि the thermal conductivity of concrete is not small enough. Not small enough, it still has a bigger value. Now, as we know, if the K has a bigger value, the more rapidly it will conduct heat. So, क्या होता है कि जितना भी heat होता है ना, it gets transferred inside the house. And if you have lived in the heat of Guwahati in a concrete house, it feels very hot. It feels very hot. Why? It feels very hot because the thermal conductivity of concrete is still much more larger than many of the substances. That's why in summer days and people are having this kind of houses, they prefer to give a layer of earth foam insulation. मतलब sometimes they will यहाँ पे थोड़ा सा insulation रहता है, ऐसे करके insulation रहता है, or the on the ceiling, so that heat transfer is prohibited, so that जो heat आ रहा है ना ऐसे transfer ना होके it gets reflected back, the heat gets reflected back, so that you feel less hot. Now these things are, this foam insulation, ceiling, these things are rich people thing. These things are rich people thing. Not everybody can afford it. So one of the very cheapest way, this is also what we have done with our houses. This is our ground floor. Make another floor. तो यहाँ पे तो कोई अभी तक नहीं रह रहा है. Make another floor. तो यहाँ तक heat transfer होने तक time लगेगा ना. So comparatively it becomes less hotter. You still feel some heat, but it will be less hotter. Now again, some people will come. Then again, if you have money, make one more floor. So this way, how the cheap things work. So this is what we call heat retention. You need to minimize the heat transfer. Fine, you need to minimize the heat transfer. Now since this is heat retention, and now if we're going to talk about heat transfer, best example is nuclear reactor. क्या होता है कि at the core of nuclear fusion or at the core of nuclear reactors, so much of heat is produced that it needs to get out. It needs to get out. Matlab that the heat needs to get transferred from one position to another. So nuclear reactors is one of the best example of heat transfer, and the houses made of concrete roofs are one of the best example for heat retention. You need to retain the heat. You need to stop the heat from coming inside. Okay, that is the thing. Fine, understood? Understood?
Yes.
So this is conduction. ये लिखा ना, joule per second per meter per Kelvin. Don't forget. Convection. Conduction was the transfer of heat. Convection is Same again, heat transfer, but by actual motion of matter. Okay, it is possible, and only it is possible in fluids. Fluid matlab ya to liquid ya to gas. Understood? Convection is a mode of heat transfer by actual motion of matter particles, and it's possible only in fluids. It is water, liquid, or the gaseous stuff. What happens in convection? Tell me. How convection works? Okay, you have understood कि अच्छा transfer of matter हो रहा है, motion of matter हो रहा है, but actually में क्या हो क्या रहा है actually? हो गया? Actually में हो क्या रहा है? बोलो तो बोलो. This is during day, this is during night. During day, you know, sea breeze occurs. During night, land breeze occurs. Now, explain to me, how does it happen? Okay, one of you explain sea breeze, one of you explain land breeze. Not need to explain, but just tell me. Achha, looking at the figure only, you tell me now what is happening. Jaldi. Come on, figure सब कुछ बोल ही रहा है. Figure is telling you lot of things. Okay. What is happening actually in daytime? Both the land and the sea will get heated up. But the thing is, land will get heated up a bit quicker than the water. Why? Because the specific heat of water is much more than the specific heat, say whatever it is, than the land. Not specific heat of land, but the land. Okay? So water will take some time to get heated up, and by that time water gets a good amount of heat. यहाँ पे तो air molecules रहेगा ना. These molecules will also get heated up, and since these molecules will get heated up, this will become less dense. इन लोग का density कम हो जाएगा. Since their density has become less, it will go up. All these molecules will go up. See this arrow? Will go up. Now यहाँ पे थोड़ा खाली जगह हो गया because there is no particles anymore. So what will happen? The air from then now what will happen? The high dense air from the sea will take its place. Understood? The high dense air from the sea will now take its place, and then this cycle will keep on going on. Garmi ho raha hai land, the moisture and everything will go up, and then it will go towards this direction, go up. The high dense air will take its place, and then the cycle will keep on continuing. This is what we call sea breeze. The cold air that is coming from the breeze to fill up this position. Okay, this is what sea breeze. Now during the night time, land cools down, but iska to heat abhi reh gaya na. Since it takes much more time than the land to heat up, by at the time the land has cooled down, but यहाँ पे तो heat अभी भी रहेगा. Again the same thing, the air molecules will become less dense here and it will go up, and as soon as it goes up, their place will be taken by the air molecules of land, and इसने इसका जगह ले लिया, ये ऊपर चला गया, then the cycle will keep on continuing, and this is what we call as the land breeze, the air which is coming from land. Fine, and these are the two very good examples of convection. See, यहाँ पे क्या हो रहा है? Exact transfer of matter ही तो हो रहा है ना. Exact transfer of matter चल रहा है वही. Convection is basically heat transfer due to the motion of matter, and it happens or it is possible only in case of fluids. Understood? Fine. Now, one more thing you need to learn about convection is that okay, this is what I have explained. यही है बस. There are two types of convection. One is forced convection and one is natural convection. Natural convection is this example, land breeze, sea breeze. Forced convection क्या होगा? In forced convection, material is forced to move by a pump or some other physical means, a pump or some kind of machine. And this happens on, say, air heating system or air cooling system, human circulatory system. Human circulatory system pump कौन करता है? Heart. That is also example of forced convection. And a cooling system of automobile engine, when your engine gets hot, जो radiator पे जो fluid होता है, that cools down the engine ना. Those are the examples of forced convection. Mechanism same है. It's just that now we are forcing it. ये naturally occur नहीं हो रहा है. We are forcing it. Our heart is forcing, our pumping the blood in our whole circulatory system. That is an example of forced convection. Natural convection, like I said, land breeze, sea breeze, best example. Understood? Need to know more? Website में मिल जाएगा. You can keep on learning. Okay? कुछ जानना है? Okay? Like I have told you, this one is a bit important. Radiation. Acha, in the earlier two cases, conduction and convection both needed medium for their heat transfer. Okay, both needed medium. एक medium चाहिए था to transfer the heat. But in this case, radiation, it does not need any kind of medium. Medium ही नहीं चाहिए उसको. It just the energy gets transferred from one body to another. It is called radiation. मतलब the mechanism or the heat transfer that happens without any medium is what we call as the radiation. Okay, that's what we call as the radiation, and the energy so transferred by these electromagnetic waves, or you can say light. Light also has some energy, na? Electromagnetic waves is what we call as a radiant energy. Okay? Understood? For now? Okay? Now, this type of energy is invisible. This radiant energy is invisible. You cannot see them, but you will definitely feel it. Okay, so all bodies emit radiant energy, whether they are solid, liquid, or gas. The electromagnetic radiation, the type of radiation, it is what we call as the electromagnetic radiation, emitted by a body by virtue of its temperature, like radiation by a red hot iron or light from a filament lamp is what we call as a thermal radiation. Matlab the energy which you are getting from, say, red hot iron, or say from light that's coming from our bulb and filament, that this thing, the energy that is coming from our light, this is what we call as the electromagnetic radiation. Okay, तुम जो देख पा रहे हो, तुमको जो थोड़ा गर्मी फील हो रहा है रूम में, because of the light, because of electromagnetic radiation. Understood? And also it's called thermal radiation. When this thermal radiation falls on other bodies, it is partly reflected and partly absorbed. Okay, and the amount of heat that a body can absorb by radiation depends on the color of the body. This is a very important one. Why color of the body? Have you experienced this one thing? In summer days, you wear less black color. I mean, जो करता है. I'm not debating on that part because somebody wants to wear, but normally people don't wear black color clothes. Okay, and you must have seen all your cooking utensils; those are black in color. Most of the cases, those are black in color. Why? Because the black color, because the black color or the wavelength of the color of black absorbs much more heat than any other color. Okay, absorbs much more heat than any other color, and that's why from this topic comes another topic what we call as the black body radiation. That's why it is called black body radiation, because initially the formulation diya gaya tha was based on the fact that the color black absorbs very much of too much of heat, too much of radiation. That's why we named it as black body radiation. Okay, that's why it's called. Depends on the color of the body. Okay, now you understood why it's called black body. See, black bodies absorb and emit radiation better than any other bodies of lighter colors. Now, what is black body? The important thing about homogeneous temperature is that it is this continuous spectrum from small to long wavelengths. The content of radiation, however, varies for different different wavelengths. What does it mean is that, see, it's a continuous graph. Get my point? This is a continuous graph for a particular object. This is something for a particular object. There will be another something for a particular object. There will be another something for a particular object. But it's a continuous graph. There is no break in it. Okay. This is for sunlight actually, which has 6,000 Kelvin temperature. Can you imagine 6,000 Kelvin? This is your lamp filament. This is a wavelength. Angstrom pe diya hai. 1 angstrom is equal to 10 to the power minus 10 meter. It's very small wavelength. So, you get my point. So that's why the important thing about black body is that, or about the thermal radiation at any temperature, you can start from any temperature and you can end from any temperature, is that it is not of one wavelength. सिर्फ एक wavelength का नहीं है. See, it is not at one wavelength. It is going from one wavelength to another, na? So that means what? It's a continuous spectrum. It's not fixed at one wavelength. Ki, it is at 10,000 angstrom. Okay, fine, 10,000 angstrom. No, it's a continuous series, but has a continuous spectrum from the small to the long wavelengths. Okay, from 10,000 to say 50,000, 60,000 angstrom. The energy content of radiation, however, varies for different wavelengths. Matlab, the energy that this radiation will have at 10,000 angstrom will be different than the energy that this will have at 40,000 angstrom. This is what they're saying. Got my point? This is energy, this is wavelength. क्या बोल रहा है? The important thing about the thermal radiation at any okay, sorry, ये temperature होगा, sorry, and ये energy होगा, जो आएगा temperature होगा, sorry. At any temperature is that it is not of one or a few wavelength. It is not of one or a few wavelength. ऐसे भी हो सकता है, same इसके लिए ऐसे भी हो सकता है. Okay, few wavelength, but has a continuous spectrum from the smallest of the wavelength to the highest or longest of the wavelength. And the energy content of radiation, जो energy होगा, however, will vary for different wavelength. इसके लिए इस point पे अलग होगा, इसके लिए इस point पे अलग हो सकता है, लेकिन in totality it's a continuous spectrum. Obviously, the point that here it point this one, and okay, this one, then again here it points is this one. So obviously it's two different things, na? But two different things of the same coin kind of thing. Got my point? Understood?
Yes.
This is what it says. Yeah, two formulas that you have to remember. One is Wayne's displacement law, which is given by this. This is lambda. Huh? Wayne's displacement law. ये वाला लिख के ना ये वाला लिख दो. You guys have to learn this ना, नहीं तो मैं ये सब छोड़ देता ना. You guys could have gone to rooms now, but you have to. And since it's the last day, so we'll have to complete it. Wayne's displacement law. Okay, wait. One thing. No need to write the second point. Write this one. Value of constant is this one. 10 to the power minus 3 meter Kelvin. No need to write this one. Write this one. Wayne's law is useful for estimating the surface temperature of celestial bodies like the moon, sun, and other stars. This formula we use heavily in astronomy and cosmology. In astrophysics also we use this formula a lot. Okay. Third and fourth point. That's important. Wayne's law is useful for estimating the surface temperature of sun, moon, and other stars. And light from the moon is found to have a maximum intensity near the wavelength of 14 micrometer. 14 micrometer. And a total electromagnetic energy radiated by a body at absolute temperature T is proportional to its size, its ability to radiate, and most importantly to its temperature. मतलब कि how big is the size of that planet, that will depend, and कितना वो emit कर सकता है, that will depend. Did you understand the last point? Last point, did you understand? Last point, basically it says that the body कितना वो energy radiate करेगा, that will depend first of all its size, how big it is, and also it will depend on the thing called something called emissivity, which is the ability to radiate heat. Okay, ability to radiate it, and mostly to its temperature. मतलब in that temperature कितना heat radiate कर सकता है for that specific mass. Understood? So this formula is very easy to understand. It's very easy to remember. Lambda m by t, and just know for a fact that it's useful for estimating surface temperature of celestial bodies, moon, sun, stars, and it's proportional to its size and ability to radiate, and most importantly to its temperature. उस temperature में कितना energy it can radiate. This formula gives us the value.
Lambda m is epsilon.
And for a body which is a perfect radiator, matlab it radiates almost say 100%. Okay, you have a body and say the perfect radiator, matlab it is radiating almost 100% of electromagnetic radiation. For a perfect radiator, the energy emitted per unit time, which is denoted by H, is called as A sigma. A is the area, sigma is the Boltzmann-Stefan constant, and T is the temperature. That means H is proportional to the fourth power of temperature. Perfect radiator matlab it's radiating almost 100%. There is no wastage of radiation. Um, experimentally it was proven by Stefan, and theoretically it was given by Boltzmann, and later it became to be known as Stefan Boltzmann law. And this sigma is what we call as the Stefan Boltzmann constant, and the value of it is 5.67 10 to the power minus 8 watt per meter square, k to the power minus 4, because temperature is in fourth power na. Last.
So it's been so long hearing all these things. Something about
Okay. Okay. Fine. हाँ sir. हो गया. Okay. Yeah, of course.